breaking news, you cannot have a triangle with sides anything you want. Okay? So if I have a triangle with, let's say, 20, 5, and let's say 32. That's not a triangle. It won't work. Okay? The sides have to fit a certain rule. Okay, you cannot have a triangle that just has any old 3 sides you want. It might not form an actual triangle, believe it or not. Like this right here will not form a triangle with having sides 5, 20, and 32. It won't work. Okay, it won't work for a reason. You'll find that reason out right now. And instead of just giving you the formula, we're going to do a nice little activity here. All right. So each member of your group is going to take turns picking straws. Now, straws. What class are we in? One more. Come on. Let's go. What class are we in? Yeah, honors, right? Honors. So the expectations are honors level. And straws? Straws in an honors class? No. We don't roll that way. All right? We're taking it up to the honors level, and we're going licorice. All right? So what you're going to do right now, I am going to give group strands of licorice here. Look at that, the extra long kind, by the way. And here's what you're going to do for me. That's why you have a ruler in every group. First thing you're going to do in this activity is you are going to create licorice lengths of 2 through 6 inches. 2, 3, 4, 5, and 6-inch pieces. So you should have 5 pieces all together at the end here. Okay, 5 pieces for me. That's your first job. Okay, and then I will tell you where to proceed from here. These are 16-inch pieces, so I'm hoping we can get the job done. 5, 9, I need probably 2 groups. Woo! Smell that bad boy. Let's get to work. However you want to cut. I don't care how you cut it either. Here we go. Cutting pieces for me. Put the pieces up. Why not another one in case we mess up, right? Or if we need to get a little, we get a little munchy here every once in a while. Here we go, in case we mess up. In case we mess up, or we have a little, get a little hungry in the group.
Number 1. Oh wait, what are we doing?
Just in case, you never know.
No, let's see. Is it 2 inches?
So write 2 inches, guys. Yeah. Right? You're wrong.
That's all 3.
What are you doing?
Got it.
Okay. So my
No, that's not gonna do it.
No.
6 is the last one. That is not a 10. Yeah, it is. Okay, so, 2, 3, 4, 1, 6. Perfect. No, I can go.
Next phase. Now you're going to take 3 pieces. Record the lengths of all 3. And then you're going to see if you can put them together to form a triangle. Now let's just make sure we're clear on the rules. What's a triangle? That's not a triangle. Don't try to stretch it out longer. Right? It's that length for a reason. Not a triangle either, with an exterior angle overhanging. Okay, that won't form a triangle. All right, record your lengths. Try to find at least, what do I have here? Try to find at least 3 that will form a triangle and 2 that won't. If there's controversy in your group, call me over. I'll decide and judge on the controversy if it is or not. Okay, so that's what I want you to do right now. Pick 3 lengths, record them in your chart, see if you can form a triangle, Try to find 3 lengths. Try to find 3 sets that do and 3 sets that, or 2 sets that don't. 3 that do, 2 that don't. And we'll see if we can find out a common theme. Yeah, exactly. All right, we ready? Let's start with the yeses. Here we go. Let's go around to different groups. You guys here, give me one yes. What'd you guys have for a yes? 2, 3, 4. Yep, that should have been a yes. Next group, give me a yes. What do you have?
4, 6, 5.
4, 5, 6. Yep, that should have been a yes. Mike, you got another one you and Kevin found out?
4, 3, 5.
3, 4, 5. Yep. All right, good. Those are all yeses. Perfect. All right, how about a couple no's now? You guys over here, you guys had a no.
2, 3, 6.
2, 3, yeah, good. 2, 3, 6 should not form a triangle. And we got another one.
2, 4, 5.
That should have been okay.
No, that was good.
2, 4, 5 should have been okay.
2, 4.
Seriously, great. 2, yeah, 2, 3, 6. Wait, they said
2, 3, 6 was a no. Yep.
2, 4, 6.
2, 4, 6 was a no. Yep.
Just change that.
Anybody have another no? There should have been one more no out there.
2, 3, 5.
2, 3, 5 should have been a no.
Oh, we did.
Okay. So here's what I want you to do. I can't give you too much time because I want to practice. Look at the ones that became yes and the ones that became no. What's the pattern as far as the side? What? Tell me a rule the sides of a triangle must follow to be actually form a triangle. All right, look, 2, 3, 4, 4, 5, 6, and again, no, they don't go in order. 3, 4, 5, but why wasn't 2, 4, 6 or 2, 3, 5 a triangle? All right, see what you guys can do in the next 30 seconds to talk it over, and what do you think the rule is? If you're going to form a triangle, the sides must together.
2 shorter sides have to add up to be greater than the long side to be a triangle.
The 2 shorter sides.
Oh, yeah, that's definitely a rule.
That's good. Well, those are 5.
That's the second one.
Because
2, 3, 5.
look at the no, it's 2, 3, 5.
2
plus
Yeah,
3
2, 3, 5 is a
equals
no.
5.
We got that right. Even though
2, 3, 6.
formal
5 does not. 5 is less
And
than
Oh wait, no.
So-
Is this not 2 through 5? Is it right? So
Yeah.
one of our
I
sides
think
has
it's
to be a
right.
little off.
Oh,
Okay, so
they have to be even.
in a triangle,
away from
the
each
2
other,
shorter
I think.
sides must be
3, 6,
larger along this side.
All right, so let's summarize. And you guys can write this right in the triangle inequality theorem that you have coming up. Your triangle inequality theorem, ready? In a triangle. I heard some good stuff. A lot of people said the smaller 2 sides have to be added up greater than the third, which is correct, but that's any 2 sides. Okay? So in a triangle, the sum of 2, I'm just going to write in a triangle, sum of 2 sides must be greater than the third. Not greater than or equal to, greater than. That's the only way a triangle will be formed. If I take 2 sides added up, that sum has to be greater than the third. All right. And yes, the easy way to do it is just take the 2 smaller ones, add them up, and see if it's bigger than the third one. That's the easy way to check. But it's got to work for all 2 sides. Any 2 sides you pick, added up, have to be greater than the third. All right, ready? A little practice now. Yep. All right, which one of these could represent lengths of sides of a triangle? So let's go through each of them and you tell me yes or no and then a why. 1, 2, 3. Could that form a triangle? 1, 2, 3. Why not?
3 and 3 are equal.
1 plus 2 is equal to 3. It's got to be greater than 3, right? 2, 4, 5.
Yes.
Yep. 2, 4, 5. 5, 5, 6. 5, 5, 6.
Yeah.
Yep. So I probably should be putting yeses and nos, huh? Yep. And hey, can I get a little bonus here? What type of triangle would that be? 5, 5, 6. Isosceles, yes! 8, 3, 8, 13, 21. Why not? Yeah, that's a no spot. And then how about 10, 20, 25? Yes, no? Yeah. 10, 20, greater than the third. All right, we're good there? Okay, here comes your challenge now. That's great, identifying if it can be a triangle or not. What I want now is number 2. I have two sides of a triangle are 4 and 7. 4 and 7 inches. What could be possible lengths of the third side? Go ahead, let's start. Just give lengths. Would 4 work? Could it be 4?
Yes.
Add up any two sides, is it bigger than the third?
Yes.
4 plus 4 bigger than 7? All right, is that the only value?
No.
All right, keep talking to me. Okay, it could be 5. Oh, here we go. Now we get the ball rolling, right? 6, 7, 8. When's this going to end? 9, 10. Does 11 work? Could this side be 11? Why not? You're correct. It cannot be 11. Why not? 4 plus 7 would give you 11. It's got to be greater than 11. So don't even try out 12. What about 3? Why not 3? 3 and 4 give me 7. All right. So these are the possible lengths, but here's how I want you to describe it. You guys remember these from last year, compound inequalities, where you had the variable in the middle and numbers on the outside? I don't know if you remember those from algebra. That's how I want you to write it. So basically, my third side, x, has to be between what and what? That's how I want you to describe these values.
Less than 11 and more than 10.
What happened to 4 and 10? I'm just asking what should go on the outside. That's what I'm asking for. And remember, you can put the or equal to as well. Remember, you have these available to you if you need it. So that's what I'm just trying to challenge you right now. What numbers should go on the outside? Should I have 3 and 11? Can I do, what's wrong with this?
Oh, wait.
Yeah, there is something wrong with it.
10.
There is something wrong with it. Yes, it includes 4 and 10. Ready? Everyone ready? Could this side be 3.9? Could this side be 3.9?
No, it would be 10.97.
Oh, I'm just asking. Could this side be 3? Is that okay if that side is 3.9? Right? 4 plus 3.9 is 7.9, greater than the third. But the problem is, it's not in your inequality. It's a valid third side, but it's not in your inequality. So that's why I can't go 4 and 10 here. Everyone see that? Because I'm still missing 3.9. Would 3.8 work? Yeah, 3.7. All right, we could keep going on. So 4 and 10 on the outside here aren't going to cut it. Because you guys just saw I'm missing values. So let's regroup. What could I put on the outside maybe now to include 3.1, 3.2, 3.4? What numbers on the outside could I put now? And you guys had it right all along. I'm just trying to show you there's only one answer and not multiple ones. 3, anything from 3 to 11. Should I put the or equal to? Should I put the or equal to, meaning including 3 and including 11? No, we just decided that didn't work. So from 3 to 11, that's it. All good. Now look, this is going to become a pain. Real quick, me having to list all those out, what if there's like 20 options? That's going to become a pain real quick, isn't it? Listing them out and then trying to figure out what's on the ends of the inequality. Is there a way I can get to my endpoints a little quicker? What were the side lengths I started out with? 4 and 7. And what were your ends of your inequality? 3 and 11. Can I use the sides I'm given to get to what my inequality should be? What am I going to do with the sides? 7 and 4. How do I get to 3? Subtract them, and how do I get to 11? There you go. That's how you can figure out real quick what your endpoints are going to be on the inequality without having to list out, oh, geez, it could be 4, could be 6, 7, 8, 9. It's going to be a while for some of these problems. So look at number 3. If my side lengths are 9 and 17, I don't even have to do a diagram anymore. I know that third side will be between, what happens when you subtract them? Oh boy. 8. It'll be between 8 and 20. Now look, that'd be a real pain in the butt, huh? If I had to list out numbers 9, 10, 11, 12, all the way to 25. That would be a pain. That's why this new method is nice. And then what about 11 and 20? Your third side would be between 9 and 31. There you go. All right. Between 9 and 31, your third side.
Absolutely.
Questions? You do what you want to do with the licorice. You can throw them out if you want. That's fine. If you want to eat them right now as you start your homework, that's fine too. All right, but we got plenty of time. You could probably even finish it. Call me over if you have questions, because some of those might be tricky tonight. Some of those might be tricky. Throw them out or eat them. Just don't leave them on the desk for me.